Welcome to another Mr. Paul video. Today we'll be discussing 4.1 representing non-proportional relationships. Okay, to understand non-proportional, let's focus on something that is proportional. So this is proportional. Proportional. Now, proportional just means that the rate stays the same, and so therefore we have some sort of relationship between two things, right? In this particular case, one thing is the months you spend working, say for your parents, and then the money earned, say the allowance. Go ahead and pause the video and see if you can fill out the rest half of this table, okay? Don't focus on this section for a moment, but just focus on this section of the table. I hope you paused it and did this yourself, but if you didn't, okay, let's move on. So let's imagine that if I worked for 1 month, I would have $10. If I did chores for my parents, they would pay me $10 for every month that I worked. So we could think of this as times 10. This is a 1 times 10 relationship. The proportionality constant is 10 times 10, okay? So that means this is times 10, times 10, times 10, and times 10. Okay, so that means 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, 4 times 10 is 40, and 5 times 10 is 50. I left this blank because I want to illustrate something coming up. If I wanted to say that this was X's or Y's, I would say that these are my X's and these are my Y's. These are the things that I put in, these are the things that I get out, and we'll be discussing more of that tomorrow and the next day. Hypothetically, what do you think this should be if I put a 0 here? What do you think that should be if I put a 0 there? Well, if it follows the same proportional relationship, it should also be times 10. And therefore 0 times 10 is 0. So what this means when we're proportional is not only do we have the same rate that follows through with every value in the table, it also means that we start at 0. Okay? We'll be learning, last year you should have learned that proportional relationships take a certain form. Meaning, for everything that you put in, we'll call those X's, everything that you put in, if 5 is the number you start with, you multiply it by the 10. Meaning you multiply it by the proportionality constant. This is known as the letter K. And that is going to be equal to the thing on the bottom, which is Y. So you learned last year that Y is equal to X times K. Now let's take an example that might not be proportional, okay? So this next example is non-proportional. Non-proportional. We're going to take the exact same situation, okay? The exact same situation in months working and dollars earned. And we're going to create this same table. So we're going to try and figure out what does it mean to be non-proportional. Non-proportional. So just to review, up here we had the same number being multiplied, the same rate, and we started off with no money. But what if I did want to start out with money? Let's just say that I didn't work at all, but I started out with $50. I'm sure you've gotten a present from Christmas, from good grades, from maybe your birthday, and you wanted to start saving after you achieved that money. I have something to start out with, therefore I want to start saving from that point on. Well, if I saved for 1 month, I wouldn't have $10 because I earned that $10 per month, sure, but I already also had $50 in my bank account. So I'm going to earn that $10, but I'm going to add it to the 50 that I already had. So this number is going to be a 60. Okay? I earned the same $10, but I already had $50 in my bank account. So the 50 plus the 10 is 60. If I worked for a second month, I would make 10 additional dollars to the 60 that I already had, meaning I worked I didn't work at all. I had 50 in my pocket, but I worked for 2 months and I had 20 more dollars to that. So the 50 plus the 20 is 70. If I worked for 3 months, I would earn $30, but I already had 50 in my pocket. So this number would be an 80. If I worked for a fourth month, I would have earned $40, right? $40. But that $40 is what I've earned in the months. I already had $50 in my pocket. So the 40 plus the 50 is 90. Now, we're going to be treating this just like our same x's and our same y's. And we're going to be describing relationships between our x's and our y's that follow a different pattern. Even though we're earning $10, the rate will stay the same. The amount that we started with will not be 0. So we can't use this exactly. As a matter of fact, we have to use a different variable for our rate, because proportional means two things. And hopefully you can remember this from last year. It meant that the rate stayed the same, sure, but it also means that you started from nothing. You started from the origin. Here, we can't call it proportional because even though our rate is still going to be $10 per month that we worked, we're not starting at the origin. That's the main difference that we're going to be incorporating in these next couple of lessons. And I cannot stress this enough. We'll be learning this over the next couple of days. If we have an input, we're going to call that x. We're going to have our input. We're going to start off with these numbers. Then we're going to figure out how many months that we worked. Well, in this case, we said, okay, well, I earned $10, but then I had to add that to 50 to get to 60. In this case, I had 2 times the $10, which was 20, but then I added it to the 70. So the 20 plus 50 is 70. So we can think of this as we're going to multiply this by the same rate. But remember, we said rates are going to be called M when we're talking about non-proportional. M times X. We can't call it K anymore because it's not proportional. We're going to call the rate M. And then we had to add this 50. We're going to call that B. And I'll explain why tomorrow. But for now, just understand that this is B. This will be equal to Y. Y equals MX plus B. In our proportional relationship, the Y represented the dollars. The X represented the months. And this was the proportionality constant. We have the exact same thing here. Okay, we have the rate. We just can't call it a proportionality constant. We have our months. And we have our dollars. But this B is what's going to be known as initial value. It's going to be an initial value. It means we're not starting at 0. We're starting somewhere else. We're starting out with a different initial value. Okay? Initial meaning where you start out. In the next couple of days, we'll be learning Y equals MX plus B frontwards and backwards and how it ties into all of this. But for now, what you should take away from today is what happens when you have a relationship between two things, but you don't start out at the origin. You don't start out at 0. You have somewhere that you're starting off with a different number, okay, other than 0. That's all for today's video. I hope that these videos are helping you guys. Stay safe, stay humble, stay hungry. Peace.